A star cluster is a group of stars that are gravitationally bound and typically formed from the same giant molecular cloud of gas and dust. These clusters can vary in size, composition, and age. There are two primary types of star clusters: open clusters and globular clusters. 1. Open clusters. Open clusters, also known as galactic clusters, are relatively young and contain fewer stars compared to globular clusters. These clusters are typically found in the disk of a galaxy, such as our Milky Way. Open clusters are loosely bound, and their stars are relatively spread out. Over time, gravitational interactions and tidal forces can cause the cluster to disperse, and its stars may eventually become part of the general stellar population in the galaxy. 2. Globular clusters. Globular clusters are more tightly packed groups of stars, often containing hundreds of thousands to millions of stars. They are typically found in the halos of galaxies, forming a spherical distribution around the galactic center. Globular clusters are much older than open clusters, with ages ranging from around 10 billion to over 13 billion years. Due to their dense nature, globular clusters can remain gravitationally bound for much longer periods, resisting disruption. Formation and evolution of stars within clusters. 1. Formation. Stars within a cluster form from the same interstellar gas and dust cloud. This cloud collapses under its self-gravity, leading to the formation of a protostellar core. As the core continues to accrete material, it becomes a young, pre-main sequence star surrounded by a protoplanetary disk. In a star cluster, multiple protostellar cores may form concurrently within the same molecular cloud. 2. Early evolution. Young stars in a cluster go through various stages of evolution, including the T-Tauri phase, during which they are still contracting and have strong stellar winds. The intense radiation and stellar winds from massive stars in the cluster can affect the surrounding environment, influencing the formation of other stars and planetary systems. 3. Main sequence. Stars spend the majority of their lives on the main sequence, where they fuse hydrogen into helium in their cores. The main sequence lifetime depends on the star's mass, with more massive stars having shorter main sequence lifetimes. 4. Evolutionary paths. Stars within a cluster may follow different evolutionary paths based on their initial masses. Massive stars exhaust their nuclear fuel more quickly, leading to relatively short lifetimes. They may evolve into red giants, undergo supernova explosions, or become compact objects like neutron stars or black holes. Lower mass stars, such as our Sun, have longer main sequence lifetimes and eventually evolve into red giants before shedding their outer layers to become white dwarfs. 5. Cluster dynamics. In open clusters, interactions between stars and the gravitational influence of passing molecular clouds can lead to the dispersal of the cluster over time. Globular clusters, with their denser and more gravitationally bound nature, can remain intact for billions of years. 6. Stellar populations. Star clusters often contain multiple generations of stars. As massive stars go through their life cycles and influence the surrounding environment, subsequent generations of stars may form from enriched material. In summary, star clusters serve as natural laboratories for studying stellar formation and evolution. The gravitational interactions within clusters influence the paths that stars take throughout their lifetimes. The study of star clusters helps astronomers understand the processes that govern star formation, the lifetimes of stars, and the overall dynamics of stellar populations within galaxies.